Good day, everyone, and welcome to another free online session at Persian Power BI User Group. My name is Vahid. I'm the organizer of this user group, and today we have a very great guest from other side of the world. Mehrdad is with us today to talk about streamlining data processes with data engineering processes with Microsoft Fabric. How are you, Mehrdad?
Hey, Vahid. Thank you. Thanks for having me. And hi, everyone. So here is 10 p.m. Don't look at this time. You know, it doesn't work. It is for my other sessions. It is basically at 8 a.m. But yeah, it is 10 p.m. And just sorry in advance if my brain is not going to with you guys. But I will try to keep myself up. Not with coffee,
great.
but with water,
That's
right?
Great. That's really great. Thank you so much for accepting my invitation. I know it's very hard to arrange this type of session, especially when the speaker is in US or Canada like you. But here is 27th of November. I can tell you about future if you want, because there is 26th of November.
but we already missed 26, right?
Oh yeah.
We are younger than you guys, right?
Oh yeah, exactly. One day. That's good. So nothing special will happen, I can guarantee for you.
Okay.
So based on what happened today here down in Sydney, Australia. So Mehrdad, I'm really can't wait to see your presentation because I saw many of your posts on LinkedIn. I know you have a great YouTube channel named Coffee Fabric. Correct me if I'm wrong.
It is Microsoft Fabric Cafe, which is the community that I'm part of that.
Yeah. I will make sure to share the link in the chat after you start your presentation. I'm a big fan of that. You invited many good speakers there. You covered many good topics there, and many of them are the very common questions in business or useful topics for all level of the users in especially Microsoft Fabric. But I saw some of your presentation in other user groups, so can't wait to see this presentation as well. I don't want to waste any time here, so let me add your screen to here, and over to you, mate.
Cool, thank you very much. So I cannot see the other screen. Wait, please feel free to interrupt me. I'm only seeing my presentation at the moment. But about what you mentioned about the community activities. It is always a pleasure to be part of that communities. And for me, the weekly sessions that we have at Microsoft Fabric Cafe, it is a learning, a new thing, and I'm always all ear to just listen to the speaker and just learn something from them. Other than that, so my name is Narda Abdullahi, based in Vancouver, Canada. I'm Microsoft Learn expert and principal data architect at Isometrics, the community lead at Microsoft Fabric Cafe, and over 15 years in software and data industry. In the last decade, I just moved to data world mostly, which is my favorite, and always a learner. And so if you would like to be in touch with me, here is the QR code. It is not a scam. You can just it's going to land you on my LinkedIn page. Let's connect if you'd like to just let's have just some connection. And below is my personal actually YouTube channel, which I'm going to just resume my videos there. I haven't been active there for a couple of months, but it is because of my little one. He's now crawling, all the way. So, but other than that, just feel free to knock our cafe door. It is 24/7 open, and just feel free. It is a self-service cafe. You can just help yourself with the different contents that we have in the community and also in the YouTube channel. You can find it, of course, in YouTube by its name. So for today, we are here to just talk about the data engineering, in Microsoft Fabric. We are going to maximizing, efficiency in modern data workflows. What we are going to talk about, I don't want to, waste your time talking about Fabric itself. I know there are thousands of, videos and presentations about Fabric, but we will have just a short introduction to that. We will just talk about the components, core components in Fabric for data engineering. We will walk you through data lake houses, pipeline, and data flows. If we're gonna just have a chance to look at the notebooks and GraphQL integration for APIs for those guys who are interested working with the endpoints and APIs, and some best practices. And at the end of the session, we can have Q&A. But feel free to just pop your questions in the chat. I'm sure Wade is going to interrupt.
Yeah,
I have no problem with that. Feel free to interrupt, but we can have the Q&A at the end of the session if you have any question.
perfect.
So with that said, let's jump into the first slide that I have related to Microsoft Fabric. So what is Fabric? For those guys who doesn't know about it, it is a unified data platform by Microsoft for data engineering, data science, and business intelligence. And the main, maybe the purpose and core, feature of that can be, it is going to integrate data storage, processing, and visualization within a single environment. So previously, before Fabric, we, had the different services, in different technologies, and we had to integrate them together and buying different subscriptions. But now everything is in one place, and Microsoft is doing a great job with this one. And there are, of course, benefits for different roles in the data industry, especially for data engineers. There are actually some possibilities to simplify the workflows and with enhancing scalability and support even real-time data processing. It is actually enables Fabric users to design, build, and maintain systems to collect, store, process, and analyze large volume of data in, I don't say in 1 second, but in shorter time, maybe. There are some, when we are talking about data engineering, there are some recommended items that you can create in your Fabric portal. So as you know, you can create your Fabric account for free. It is around $17,000 credit for you to utilize it for 60 days. So it is a great opportunity for developers to work with this, great product. So the components that we have in data engineering are the data lake houses. Data warehouse is not part of the data engineering, but it is good to mention about this guy, which is, optimized storage for structured data. And we've got the notebooks, pipelines, data flows, and APIs for GraphQL. We can have a look at it. I just jump into my slides and my Fabric portal. So let's here is our Microsoft Fabric portal. That hey, by the way, how was the Ignite? Are you interested about? I do like this databases and the latest announcements. But let's go to the data engineering experience. Here you can see we have some recommended items to create. That is the data, lakehouse, notebook, environment, Spark job definition, data pipeline, and API for GraphQL. Even you can import your notebooks, which are the files. We will just talk about most of them, but let's just introduce this one. About the environment. In the environment, you can just create your environment for actually developing and creating your pipelines and creating your libraries of when you want to program on top of your data for transformation or any kind of analytics that you're going to need in that coding system. And also for the rest I will just talk about them one by one. So before we jump into each of those components, let's talk about the architecture of Lakehouse. So any let's say any data solution that we are talking about is basically gathering the data from somewhere, transform it and store it in somewhere else, and then consume it for it is very famous architecture and flow of the data. So here we have the similar thing that we have the data storages. It can be structured data like tables, like Excel files, for example. And we also have unstructured data that can be some data like Parquet files. I don't know, the CSV files sometimes. Sorry, the CSV can be considered as structured, but for unstructured, we can have JSON files, and we can also have the shortcuts to the external data sources, right? And then we're gonna ingest that data by shortcutting to that one, or creating the pipelines and data flows to gather the data, and then we can just store it in our lakehouse, which is a storage for our data. And then we can transform the data by using the notebooks and data flows. And at the end of that, we can just consume it in our Power BI report, or creating the reports and visualizations on top of that. So we will just talk about each of these guys one by one. Data lakehouses. We're gonna start from the middle, where we store the data. So the data lakehouse is a hybrid storage solution that basically unifies data lakes and data warehouses. It is a combination of flexibility of data lakes that you can put whatever files, data files that you have there. And also, it is giving you the opportunity to use the structure of data warehouse. So the name of that lakehouse is coming from this combination, and it is supporting both analytics and machine learning workflows. How to create a lakehouse in Microsoft Fabric? There are different ways to create it. From anywhere that you can see the create data lakehouse where it makes sense. For example, we have it from data engineering homepage that we saw in the previous slide that I just showed in my portal. We can create it in the workspace view or from the create page, or even we can create it via actually the REST APIs for Fabric, for those guys who want to just automate something, or manage the Fabric items from outside of Fabric by coding. And for example, you create a Microsoft form, or Microsoft let's say Power Power Automate. So you can just push the request to this REST API and create your lakehouse. Or even you can just create it within other items like notebooks, right? And lakehouse has the integration with Git. So for those ones who doesn't know about Git, there's a data, actually a source control system that you can use to just control your actually track the changes in your items, and then you can just version them, and just having a history and a control on your source code. And not everything from lakehouse can be tracked, and I mean, the data is not going to be tracked, but we have the metadata of those lakehouses. For example, the logical ID of that lakehouse, or is if there's a description or the name of that, because these guys are going to be utilized in, for example, notebooks when we are referencing a lakehouse for doing some sort of data transformation. So and when we want to deploy the actually the notebook, for example, for the production side, for the production tenant, then we would need to have those IDs to be aligned with what we have in our production environment. And there is also a nice thing in Lakehouse, which is under preview, which is the Lakehouse schema, that you can just have some sort of categories, and just having the categories in your Lakehouse, that underneath of that you can have tables, views, functions, etc., and stored procedures. So let's go to let's go to my portal and just show you how it does work. So here, from the main page, again, data engineering, we can create a lakehouse from here. We can go to our workspace and then say new item. For the new item, we can look for lakehouse, for example. We can create it from here as well, or even from the create page. We can create it from here in the under data engineering section. We have the lakehouse, so we can just give it a name. Let's say Persian user group lakehouse 01. And as I mentioned, we have the lakehouse schema. It is in public preview. It can be created with this, and it can be created without this. For those guys who don't want to just put their lakehouses on risk while it is not generally available yet, so they can just untick it. And let's create it. So when you create a lakehouse, basically you're gonna have two main sections, right? It is tables and files. For the files, you can just upload your files, or transfer the files from somewhere else, and then those files can be loaded as a table, or even the tables itself can be loaded while using, for example, the let's say by uploading with the sample data, it is going to be directly there. Let's just have a quick load of sample data. if it is going to open. You can just, something is already loaded, the public holidays. And the database basically is going to be stored as delta tables. As you can see, this little sign here is the sign of the delta data. And what does it mean is that if we look at the files behind that, we have the Parquet file, which is the actual data there, and the delta log that is basically is going to keep track of the changes for your data, right? And what I wanted to mention about, when you create a lake house, let's go here. When you create a lake house, it is basically is going to create an object which is called SQL analytics endpoints that you can use for querying your data using SQL. For those guys who are familiar with the SQL, you can just make the new query and then select 10 whatever from this dbo.public holiday and then run it. Awesome. So let's back to my slides. The next item in our, so far we just talked about the lake house. Let me just show you something as part of the demo. I have a workspace here that I have loaded some sort of data. The data that I have loaded here is Worldwide Importers Lakehouse. Worldwide Importers, for those who doesn't know about, is a sample database built by Microsoft for doing your test and learning about just as a material for doing your tutorial and doing your tests. It is a fantastic data warehouse, and basically I have loaded the raw files here, and how we're gonna load it, I will let you know. So initially I loaded the files, and after that I will show you how the data has been landed to the tables. So we've got the pipelines and data flows. The purpose of pipelines in data engineering, which we had it in Azure Data Factory as well, was the automating actually data processing and ensure actually repeatability. It is basically doing an orchestration of the data activities, like copying the data or even transforming the data by using data flows. And the data flow Gentoo is also in Fabric, that it can be reused actually for the ETL processes for extract, transform, and load of the data for for the transformation tasks. I'm not going to talk about those core stuffs about what does mean about the transformation, but data flow is part of that, and it is doing a great job by using the Power Query and some built-in components that we have there. But pipeline is one maybe a step above that, which is orchestrating all of these guys, and it can be scheduled or even executed on demand, right? And for doing the data load and transformation, of course you're gonna define the source, setting your transformation steps, and then configure the destination setting. How we have done it in my demo. Let's go to my workspace. I have created a pipeline here, right? This pipeline is basically uh, loading the data from an HTTP, from an HTTP, source, which is reading, from this. If I can open it, it is a simple one. It is just copying the data from a HTTP URL, and then just upload it to my destination, which is the Worldwide Lake House as a file. And the file that I've actually shown before was part of this execution. And if I want to just show you the run history that I have executed the previous time that was successful, you can just check here that how long it took time. It was around maybe 40 to 50 minutes 50 minutes for doing this activity. And as you can see, the data that we read was around 2 gigabytes, and when it was written back to Lakehouse as files, it was around 76 gigabytes. So it took around 50 minutes. But of course, it is an initial load, right? You are not going to load this amount of data and wait for this time for every single loading data, right? This is for the initial load. Then you can just set your incremental loads, and it is going to be shorter and shorter for sure. And it depends on your use case, that how often you want to just load your data and refresh your data. Cool. So with this pipeline, we have loaded the data in these files. The data is there. And what else? We need to load this data as tables on top, right? It can be on cells or dim. So in dim as dimension. And these are the schemas that I have created before. For creating the schemas, you can just create new schema from here, and then it is going to be available for you. And when you go to SQL analytics endpoint, then you can create your views, functions, and stored procedures. But in data lake section, you only have the tables at this stage. Let's back to my slides. So we have loaded the raw data as files in our lakehouse. Now it is the time to transform it and load them to the tables. How we can do that? There are various ways. One of the ways that we can use is using notebooks and Spark jobs. So what is the notebook? The notebook is basically a code-based interface for data exploration, analysis, and visualizations. That there you have to write codes. That can be in Python. It can be even in SQL or Spark SQL, in Scala, whatever that you are, comfortable with, and it is going to meet your needs. The notebook itself is an interactive one that you can just execute your code and see the result, right? Or store your result, on demand. But if you would like to make it automated, or you want it to be executed at specific time, then you can have your Spark jobs that is going to, for just executing those, Python codes in an interval, or at a scheduled time. There are some best practices. We're going to utilize distributed computing for efficiency, which Fabric is doing that, and leverage built-in functions and libraries. So the more the more knowledge that you have in Python, the more complex stuffs and easier you can create your data analysis and data transformation for sure. So let's have a look at it and see how we have done it in our demo. So what we are going to do, what we have done actually, was reading the data from these files and write them to the tables in our data lake. So I have created a notebook for create delta tables. It is the first thing that I do, right? But there are some, let's skip door. Before that, let's just have an introduction to the environment of notebook that we have. In the left side, we have the Explorer, which we can create some sort of data sources, or even we can create the folders there and put our resources. And even we can load the lake houses and warehouses if it is applicable for us. And if we want to just refer them, just reference to them, having reference to them during our code. We want to read or, actually write the data. Then, in order to do that, you can just add your lake house. It is going to just ask you, it is a new lake house, it is existing lake house with a schema, or it is an existing lake house without a schema. And just remember, one of the ways for creating the lake house is here, that you can create a new lake house. And then, here are the explorers. The rest are, where you can, add your code sections. When you're adding your code section, one part can be the code like this, or you can add it as a markdown, as a comment or something like that. The good thing about this environment is that you can add comments, right? For example, if you want to add a comment for your peer, for your manager or developer, that you can just say, hey, you can just mention them, right? In your organization, just look at this data, or this, way of the development is not correct, or something like that. You can just having some comments there, or some additional description regarding this. And there are different views that you can just develop: run only, edit, or only view. That for each of those guys you can do something specific. And here you can just choose your language that you are going to develop with. However, for each of these codes, you can change your language, by using the actually tag as well. But let's back to our discussion. We want to create the tables. So for we have two type of the tables: fact tables, in the data warehousing architecture. So we have the fact tables and dimension tables. For the fact tables, we have the one fact table, which is the fact cell. And here, we are loading the data from this file. The file format is Parquet. And then we are adding some columns. We are actually having some derived columns that is going to calculate the year, quarter, and month from the invoice date key. These are some just examples that how we can transform our data, how we can add an additional column for our fact table. And then we will just overwrite it in Delta format. And it is going to be partitioned, in order to have a optimized, table for having, faster, reporting and exploring the data based on your use case. Again, it needs a one step behind this, right? That is about designing. So before jumping into the codes, of course, you're gonna design your data model. What are the expected reports on top of your database and your lakehouse. So I want, for example, the manager says I want the the reports based on the year and quarter. I'm not interested in the day or month even. So we will partition that by year and quarter, and then store the data. We also have other kind of tables. It is the same story as top, but there are other transformation. For example, we are removing the photo table, photo column from the dimensions. Right, it is not required for us for creating the dimension tables. And then as you can see, we can utilize the for each loops even. Sorry. Awesome. So step number one, it is only creating the tables, right? The next step is, let me just bring it. We have created the tables and loaded the table, loaded the data as is in our table with some sort of transformation. But we may need some additional and advanced transformation afterward, or maybe we need to create some aggregations. Like I just want to talk about a little thing about, for example, medallion architecture in Microsoft Fabric that is talking about your data in 3 steps: bronze, silver, and gold. Right? That in the bronze you load the raw data and then to transform it somehow, and then in the last one you're gonna aggregate it and prepare it for the reports that your Power BI is going to use that semantic model for doing the analysis. But here is an example of aggregating of the your fact table and creating a new table. So there are different approaches that we've gone through. Actually, for one approach is using the the Python code, and also we can utilize the SQL code if you would like to load the data. Actually, if you are interested in SQL and you're comfortable with SQL, so how you can see how flexible are the notebooks, right? That you can write your code based on your interest. But sometimes SQL is not a good fit for your basically your needs, and you have to switch to the other languages based on the use case that you are having. But however, it is some sort of aggregation that is happening in this code. I don't want to be that detailed on that, but at the end of the day, the data is going to be loaded into the lakehouse. If we look at it, these are the two. Sorry, here. These are the two tables that we have created from the facts, fact cell, but it is aggregated by date city or aggregated by date employee, based on the required reports in our Power BI, for example. And the other thing, so our data is loaded in the tables, but on top of that, we would like to just report on them, right? We need a semantic model. So of course, the fact tables and dimension tables are somehow in relationship with each other. For example, in the cells by date employee, the employee is linked to the dimension of the employee. So we need somewhere to link these guys together, right? For example, I'm just looking for the item that I've added recently, the semantic model that I've created here. And oh, sorry. What was that? Come on. No, sometimes I have to look for the button, but however, the data is in this. So we have created the semantic model, and on top of that, I have created the report that is going to load those that semantic model and creating the reports on top of that, right? So let's back to our presentation. Cool. We have created our data lake and the tables and whatever whatever aggregation that was required. We've done it there, and we built a report on top of that. Another type of the data consuming will be the APIs on top of the your data source, like your lakehouse that you can create with the the API for GraphQL for API, which is a component of data engineering fabric. It is a developer-friendly tool for the actually API query language, actually for those developers who are interested in typing in JSON and they want to retrieve specific data on demand. And it can be utilized in their applications by just sending the request to those endpoints and APIs and getting the data. And basically, one of the benefits for data engineering is that reduces data retrieval latency and query inefficiencies. How to do that? Let's have a quick look at it in our workspace. We can create a GraphQL API for GraphQL. Actually, it became generally available in the latest in Ignite, but it is still showing the preview. But however, version user group GraphQL 01. Let's create this guy. So it is very simple. We create it. We select a data source. The data is going to be loaded. So it is new somehow. How we're gonna connect to the data sources with single sign-on authentication, whatever that we have, you're connected to, or external sources using a saved credential. So let's connect to the one that we have. For example, the worldwide importer lakehouse. Connect to that one, and we can choose the data that we need to be loaded there. Of course, not all of the data is going to be required, but let's say, for example, the fact cell is required to be loaded. And then it's going to be provide us with an intelligence load that we can just say query, for example, and then just there we can call it as fact cell, and then items, let's say the customer key, and then total including tax, whatever. And then we can just run it. It is going to provide us with a result set of the items that are only for the fields that we need from actually the columns that we need from our table. And then the good thing is that we can generate the code. For those guys who are familiar with Postman, it is doing the same thing, right? You can just generate the code and then use it in your application in different languages, in Node.js or in Python. And of course, it is going to give you an endpoint that you can again utilize for connecting to this specific service. There are some tips and maybe tricks for optimizing data workflows in Fabric, that you're gonna use the key tools, right? You're gonna use the lake houses, which is centralizing structured and unstructured data. Of course, you're gonna use partitioning for performance based on your use cases. You're gonna use pipelines to automate the ingestion, transformation, and delivery, and which is going to leverage the event-driven triggers. And you're gonna have the data flows and notebooks for data transformations, for efficient data transformation that are going to be reused. For example, for the data flow, that you can have incremental loads based on a date column that to just check if anything has been changed. For example, just load the data from that specific date and not loading everything. And another technique and tool that you can use is the direct lake in Power BI, that is going to enable low latency analytics without any duplication. You don't have to duplicate your data. You can just directly access your data for Power BI reports. And there are some optimization techniques. Again, let's back to top. Partition large data sets by dimensions like time. You can cache frequently accessed data. Use incremental refresh to reduce processing overhead. And some best practices for workflow efficiency we can mention about design and monitoring. In terms of design, I mentioned it in my earlier slides, that before jumping into the using the features, using the tools, and creating the partitions, before that we need to design our data model. It is an obvious thing, right? That you can just add up star or snowflake schemas for analytics. You're gonna need to minimize joins and filter data early. Sometimes you have to flatten your data up front to just have less joins, and it's going to be massively beneficial for your analytic processes. And you can also use built-in Fabric monitoring to track the performance in terms of the monitoring. In terms of the automation and scaling, it is always recommended to schedule your jobs during off-peak hours, when the servers are in lower intention. So it's good to have your jobs in that time. And the other thing, about the security and governance, we can mention about applying the role-based access control, or monitoring workflows for compliance like GDPR and blah 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 blah, that you can use, for example, Microsoft Purview for this purpose. So it is open floor. If you would like to, if there is any question, Wahid. I think.
Well, thank you so much, Mehrdad. That was a great presentation. You cover many areas in 40 something minutes. That was great. I really like it. Actually, there is no comment. I think you cover all areas, and that's clear to everyone. So there is no comment here. So, do you have any other present slide, or do you want to cover any other things, or that was it?
I wanted to mention some stuffs. Can I share my screen?
Yeah.
These are some additional tips that can be utilized by designers and data engineers. Sometimes we are about to make the decision, what should I use for copying the data, for example, for bringing data. They're going to be confused sometimes that should I use pipeline, should I use data flow, or Spark job? So there are some documentation from Microsoft Learn that is comparing them for you, and based on them, you're gonna just choose your the best option that works for you better. For example, here we've got the comparison between pipelines, data flow gen 2, and Spark. If you are looking for no code, low code, we can use pipeline and data flow. If you would like to code, then it is for the Spark, right? If you're looking for hundred of connectors, then you can just use the Spark, or which have the libraries. But if the connectors and data flow gen 2 or pipeline is meeting your needs, then you can go with this. So, and other kind of scenarios that you can just have a look at them. Or another decision guide which is related to the choosing a data store. What kind of store I should use for, actually what kind of database should I choose for my storage? And is it for example, if it is unstructured, semi-structured, or structured, you can have a combination of them. You can have make use of lakehouse. If it is only a structured, then go with the warehouse. If it is you want it for real time, then you're gonna go with the event house and KQLs. Or there is another guide that I can just we can share the links from here afterward. But sometimes you need to choose between warehouse and lake house. There is a questionnaire here that you want no code or pro code solution. How do you want to develop? If it is Spark, then use lakehouse. If you would like to develop with TSQL, go with the warehouse. And again, you need the multi-table transactions, go to the warehouse. If not, lakehouse, and so on and so forth. And yeah, that's it that I wanted to share. And also some
That's great.
great items from Ignite that came out for the new announcement that we have. Of course, you can just have a look at it. For example, for the data engineering side of the things, these are some upgrades about the charts and notebook. We have the Fabric API for GraphQL is now GA with exciting new features. We've got Esri ArcGIS, which is fantastic to have it. Many of the guys were looking for this, and yeah, and some sort of this. Yeah, cool.
That's great. Thank you so much, Mehrdad. This last part was very important. That's a question everyone asks. Okay, we have million things in the Fabric, which is a great actually thing for us. If we have every tools in hand, we can build whatever we want. So this is the power of Fabric. You have everything you need to architecture in the way works best for you, and then use it in that way. So thank you so much, Mehrdad, again. Thank you everyone for attending this session. We will have another session next week, which I will share the information in LinkedIn, and other social media channels. So thank you so much, and see you soon.
Thank you very much. Have a good one. Cheers.
Cheers.